Hi, everybody. Welcome back to Environmental Organic Chemistry with Dr. Lisa. Today, I want to give you a quick tutorial on how to use the UFZ-LSER database. It's available here online. Before I do that, though, I want to just quickly run through with you some of the differences between this database and the EPA's EpiSuite software. EpiSuite is a lovely program that I've been using for many years. It's got a lot of good things going for it, but it has some pros and some cons. So the EpiSuite software is a free download from the US EPA. It gives you all kinds of partition coefficients like Henry's Law and log KOW and many, many useful things. It actually does some of the calculations of partitioning for you if you set it up properly. And it has a lovely module that allows you to calculate partitioning in a sewage treatment plant, STP. So it's got some real pros to it. The big cons with EpiSuite is that it's no longer being updated. EPA created this software many years ago, and it's no longer being updated. As is typical of EPA-supported software, they only provide a PC version. There's no Mac version. It was written for Windows 7. How many of us still have Windows 7? Not me. And because of that, it is tricky to install it on a newer computer. Many of you are running, I'm still running Windows 10, but a lot of you are up to Windows 11 now. It can be done. You can install it and run it on a newer PC, but it's a little tricky. For those of you in my class, there's a PowerPoint slideshow of how to do that, how to overcome some of the issues that you get when you try to install the EpiSuite software on a newer computer. That's posted on our Canvas site. But it's tricky. So it also, getting more fundamental, it uses bond and group contribution methods to predict things like Henry's Law and log KOW and stuff like that. And I have seen some scientific literature that suggests that that approach is less accurate than the polyparameter method that is used by the UFZ-LSER database. So I don't think the differences are huge, but as far as we know, the polyparameter method is a little bit better. Another big shortcoming of the EpiSuite software is that it doesn't give you any delta H terms, whereas the UFZ-LSER dataset does. And it also, as far as I know, does not have any sectional constants in it, whereas the LSER dataset does as well. So there are some real pros to using this LSER dataset here. So how do you use it? Well, pretty straightforward. You can, I mean, I don't know who uses Smiles. Maybe there's one person on the earth that uses Smiles, but most people are either going to search by the CAS number or by the compound name. So let's say we want to look for atrazine. We put that there. We hit search. And in the case of atrazine, you're going to get a lot of different choices here. I'm not totally sure what the difference is between all of them. Typically, if I'm only going to choose one, I choose the LSER dataset because that makes sense to me, but you're also free to choose all of them. So we'll just choose all of them for this demonstration. And then over here, there's all these choices, right? You can choose to look up parameters for partitioning between water and solvents, solvent to air, solvent to solvent, aerosols, biological materials. That would be things like lipids and cell walls. Delta H predictions, as I said, that's here, that's really useful. Water, so that would be things like aqueous solubility, that's very important. Technical sorbents, carbonation sorbents, this is where you would find things like log KOC. Other surfaces are here, and there's a bunch of other stuff here too. There's Freundlichs and biopartitioning and membrane permeability that I'm not even going to touch on in this video, but there's a lot of great stuff here. And backing up one moment, the other thing you notice is it's a website. It's not a downloadable software, which is a big advantage because, as you've seen, for EpiWin, that's a big problem, is that the version of the software is now incompatible with newer operating systems. And so the fact that they made this a website, I think, was really smart. There's no need for you to download software. And by definition, that sort of means that they have to keep it updated so that it will continue to be useful. Okay, so I've selected all of the different data sets that I'm going to use, and now I could go in here and let's say I wanted to find a log KOW value. I might go to solvent water here. And here I've got lots and lots of different choices here. I could choose any or all of them. Up here toward the top, I have wet octanol. So that's probably the most useful in terms of that's what we would think of as log KOW, would be wet octanol. But once you click on any one of those menus on the previous screen, you also are getting all of them down here. So you're not limited. So we could also maybe go look up a organic carbon to water partition coefficient. Notice we've got 2 of them, so let's do both. And maybe we also perhaps want to, for some reason, underwater is where they put the water to air partitioning. Don't ask me why it's here and not under solvent to air, but it's here underwater. So maybe I want my Henry's law constant. Here's my KS value, my session out constant for salting out. There's one for sodium chloride and there's one for ammonium sulfate. Obviously, if you're dealing with seawater, you want to choose the one for sodium chloride because mostly seawater is sodium chloride. And then you can also go to delta H predictions here, and it's got the delta H predictions for lots of different systems. It's got octanol. Now, unfortunately, I cannot find anywhere in this software, in this website, where they give you the delta H term for water, just dissolving the pure liquid or pure solid into water. Unfortunately, I don't see that anywhere. But it does have octanol here. And it also, if you go down here to the solvent air, just keep scrolling down, here's the water to air partitioning. So I might want those. And so you can choose any or all of these, as many of them as you want. All kinds of good stuff here. Dimethyl carbonate, acetone, everything you can think of. I mean, not everything. Obviously, atrazine is a pretty well-known, well-studied chemical, and as a result, there's lots of information here for atrazine. If you're looking up information for a less well-known chemical, you're not going to have as much to choose from. But for atrazine, we have a good selection. And when you've selected everything you want, you just go down here to calculate, and that will automatically cause you to download this LSER calculations file, and it looks like this. Okay, so here's your general information. These are the polyparameter equations used to calculate the different partition coefficients. Here's the experimental description. So for example, here's the alpha and beta values used for partitioning for atrazine. I believe S has to do with size. Alpha and beta have to do with hydrogen bond donating and accepting terms. Here's the equations that were used, and they even give you references for them, so you can go look up the papers. And then here's some of the actual equilibrium constants. So here's the octanol water partition coefficient, a log KOW of 2.28 roughly for atrazine. If you are looking this up and you have a lot of values to choose from, you can choose one, you can use the average, whatever you decide to do. Whatever you decide to do, I would be consistent. Here's the carbonaceous sorbents. So here's your log KOC, organic carbon to water, log KOC. Even gives you units in case you forget your units. Here's the water to air bulk phase partitioning. So this is Henry's law, but notice this is log K water over air, not log KAW. This is water over air. So this is KWA, for example. And so if you want KAW, the log KAW would be minus 6.09. You'd have to flip the sign because you're reversing the numerator and the denominator. So you'd have to flip the sign here because this is a log. So that's very important. Don't make that mistake. They're giving you water to air partitioning. And then also here's the session out constant. Again, you might have to choose an average or choose the one you think is best or whatever. Doesn't matter. And then here's your delta H predictions. They're given in kilojoules per mole. So the dry octanol, again, you learned in my class, all of you watching this lecture, and maybe some of you who are watching this have never taken my class, but you know that this delta H term for dissolving into octanol is usually pretty small. So yeah, it's 10 or so kilojoules per mole. In this case, it's negative, which is telling you that atrazine is forming hydrogen bonds with the water, which is quite favorable and gives you a negative delta H term, but it's not huge. Here's the air to water bulk partitioning, and that's much, much bigger because that involves taking the chemical out of water and into air. So that is, I'm confusing even myself. Yeah, so that's much, much larger. Sorry, this is water. So it's actually got a slightly negative delta H term for partitioning between the water and the octanol. Sorry, I was getting confused. And then here's your air water bulk phase partitioning, which is usually much larger because you have to launch the chemical into the gas phase, which takes lots and lots of energy. So this is strongly related to delta H of vaporization. Now, again, they don't give you delta H of vaporization here anywhere, but they do give you lots and lots of values for the water to air bulk phase partitioning. And from that, you could probably back out the HEW term and perhaps also delta H of vaporization. So very, very useful stuff. And getting back to my quick PowerPoint here, I just want to point out that the UFZ-LSER database doesn't have delta H of fusion, which is unfortunate. I think that's probably because delta H of fusion is just so difficult to predict. We talked about that in my class. It's just really, really tricky. So nobody has a good way of predicting delta H of fusion yet. It also does not have the HEW term, which is the excess enthalpy for dissolution in water. That's a term that we often wish we had in my environmental organic chemistry class. But it often will have delta HAW, right? Partitioning between air and water. So that's the delta H for Henry's law. And we know that the delta H for Henry's law, this delta HAW term, is equal to the delta H of vaporization minus HEW. And so if you can look up delta H of vaporization, which sometimes you can, or you can estimate it from the Gauss and Schwarzenbach equation, then knowing this, you could back out HEW. So you can at least get some estimate of how big HEW is. So this UFZ-LSER data set is really, really useful. I highly recommend it, and it's not too difficult to use once you know how. And I hope that you guys will continue to use it in my class because it's really, really helpful.